At this point, you already have evaluation results. The next step is to take those results to make targeted prompt changes. Prompt updates should be based on observed failures and measured outcomes, not intuition. There's an important distinction to make here. Manual iteration versus automatic optimization. Manual iteration refers to directly editing the prompt yourself. It's most useful early on, when the prompt is new and needs obvious fixes. It's also necessary whenever you want to add new capabilities or change the behavior in a way that can't be inferred automatically. Once you have a prompt that's working in production and handling many real-world use cases, automatic optimization becomes the better tool. At that stage, the goal is not to reinvent the prompt, but rather to continuously improve reliability based on data. In this track, we'll cover both approaches. We'll start with manual iteration so you understand how to diagnose issues and reason about changes as an AI PM. Then we'll move towards automatic optimization, where the same logic is applied at scale. So, how do we decide where to focus? We begin by reviewing your evaluation outputs and annotations. Your first task is to decide what is worth fixing. Not all issues should be treated equally. For each issue, ask two questions. How often does the issue occur? And how serious is it when it occurs? Issues that are both frequent and high impact should be prioritized. This type of prioritization is a core responsibility of an AI PM. Once you know what to fix, you need a consistent process to validate that your change actually improves behavior. Use the same loop for every iteration. Identify, hypothesize, modify, test, and evaluate. This structure turns prompt iteration into a controlled experiment and avoids the common flaws in prompt engineering of throw every solution at it and see what sticks. Step 1 is identifying a specific issue. First, we start with evidence from your evaluations. Don't attempt to improve the prompt in general. Instead, identify one concrete failure mode that appears repeatedly. This keeps the change focused and makes the outcome easier to measure. Step 2 is forming a hypothesis. Next, make your reasoning explicit. A useful hypothesis is specific and testable. If I change X, then Y will improve because Z. For example, if I add clear grounding instructions, factual accuracy will improve because the model has less ambiguity about source material. This step ensures that changes are intentional rather than reactive. Step 3 is modifying the prompt carefully. Now, we make changes to the prompt. We only change one thing at a time. Single variable changes are critical. If multiple changes are made simultaneously, it becomes difficult to understand what caused an improvement or a regression. Over time, this is how prompts become difficult to maintain. Step 4 is testing under identical conditions. After making the change, we rerun the evaluations using the exact same setup as before. We use the same dataset, the same evaluation logic, the same metrics, and the same success criteria. This is required for a valid comparison. Step 5 is evaluating the outcome. We review the new results, and we ask the following. Did the targeted metric improve? Did behavior change in a way predicted by the hypothesis? Did new issues appear elsewhere? This step confirms whether the change was beneficial or should be reverted. Choosing what to change depends on understanding where different issues typically originate. For example, repeated factual errors usually indicate missing or weak grounding context, or issues with retrieval or tool usage. Outputs that are technically correct but stylistically incorrect often point to tone or instruction clarity issues. Off-topic responses usually indicate that the task definition is unclear. Tool call failures, however, are typically related to structured output constraints, temperature, or model selection rather than tone. Not all problems come from the same part of the prompt. Distinguishing between these categories is part system understanding and part experience.
So let's start fixing up our prompt. The first thing we need to do is we need to go to our issues and we need to decide what issue we're going to approach first. All right, so move over here, we're in our issues, and here we have the two principal ones, which are equally urgent. And we know they're equally urgent because here we have 9 events tied to each, okay? If you'll recall, those events came from our annotations. If you'll recall as well, and we'll go back here, we go to our festival chatbot, and we go to our experiments, you'll recall that we did this first experiment with our evaluations, okay? And here, we had an average of 2.5%. And actually nearly on every log, we had there's actually those two issues appeared simultaneously. So what we're going to do today is we're going to go in and we'll fix both of them. And actually, I suspect that because they're occurring simultaneously, frequently, and also that these issues, if you recall, we were talking about tool call issues like this and tool extraction issues. We were talking about how those often have to do with the model. And so I'm suspecting that by doing a simple change, we might fix both of them. Okay, so let's go over here to our festival chatbot. And here, quickly, I'd like to draw attention to one thing. So right here, you will see that we have changed the URL for the prompt. We just had some issues with the Notion page that we were hosting. And so we've created a new web page with our festival policy information. The link for this will be in the description. And you can just grab that and paste it in here, okay? So how are we going to go out fixing this? As you recall, we need to make a hypothesis. And then we need to test that hypothesis with a single change so that we can understand scientifically what actually fixed our prompt, okay? So as we spoke about in the theoretical section of the video, these types of issues with tools are probably caused by the model, okay? And let's go here and look at our model. So we have GPT-4o mini. Now, the issue I see here is that we have an older model. Firstly, we have GPT-4o, and simultaneously, while having an older model, we have a smaller version of that model. Now, that might also affect the performance in tool calling or in the context window. These smaller models, while faster and cheaper, might have some issues at that level. So what we're going to do here is say, I think that the problem is the model. And so I think that we can solve that by switching to a more modern model that's perhaps a little larger, okay? So let's go over here and go to our models for OpenAI, and let's switch to probably 4.1. Okay, let's go look at our models for 4.1. We have 4.1 mini and 4.1. Let's test first 4.1 mini, so we don't have to increase the model size, okay? And now that we've made that change, you'll see here it's gone to GPT-4.1 mini. We can go in and we can preview and see if we have those double tool call issues, okay? So we're gonna go down here and hit preview, and then I will select a log from our data set that we did prior, if you recall. Festival experiment data set, okay? And we're gonna fill in these variables. So username and then customer query, and let's give it a run. Let's see how this works. Okay, awesome. So we fixed that up. We had a single tool call here, all right? And then we were given a nice JSON response. So now what we can do is actually we can go look into this trace here. And if you rewrite here, we have our evaluations, right? And you'll see here that we have 2 out of 2. That means both of the evaluations passed in this case. So with that simple change of model, we've perhaps solved both of our issues. Now, of course, this is just a single change and this is just a single example. So we could perhaps run a couple more and see how we're doing, but this is a good indication, okay? So let's go back to our editor. Let's go to the preview and go to our data set. Select those variables again. Alrighty, and let's run it with the second row. We just do that up here at the corner. Run. And okay, we have a single tool call and a nice JSON response with category and response. Awesome. If we go check the traces again, it seems that that was also functional. Awesome. So we have our evaluations are looking good on that. So here we've seen a simple practical example of how you can look at an issue or various issues, and you can make a hypothesis about what you think is causing that issue, and then make a targeted change and test that change and see if it was successful. What we'll do in the next video is run the same experiment that we did in the previous video, and doing that, we'll be able to see if our prompt has truly improved with more examples, okay? See you in the next video.